My phone had to be bought by a math teacher. It's like, why the hell? Poor little dude. Or dudette. I have no way to tell. Okay. Is that cool? I mean, hopefully you guys understand this is not done, but so you get 39 plus 36 plus 31 plus, and then you just add them all up. Right? The last one's going to be negative. Okay, cool. So a lot of math actually ends up being like that. Really easy if you just remember what the symbols mean, what they're trying to ask you to do.
Is 12e negative 1?
12, which one?
12e.
12e? Well, let's see. I like, what's this one curveball I threw into 12e? Yeah, it's a negative power. So what would you do first?
1 over.
1 over. Now, how do you figure this out? I don't know. I've shown you several different ways. So I would do 4 goes into 23. Who cares? Remainder of 3. So it's the same thing as 1 over I cubed. What's I cubed? Negative I. Oh shit, are you done? Oh, Jeff, what the hell? What kind of problem is this? That was me, unfortunately. Why am I not done yet? Because this is not a complex number. This is a problem that you have to work out. What do I do? Who remembers what I do here? You multiply by I. I like it. So you get I over negative I squared. What's negative I squared? What's I squared? Negative 1. Negative 1. So you do get I. You suck, Jeff. Oh, well, too bad.
Is that a 1 over IQ?
Yes.
Square? No, right there.
Because 4 goes into 23 5 times with 3 remaining. So I to the 23rd has the same value as I cubed.
Okay.
That's cyclic thing. Every fourth one it starts over. Yes? 11 F? Oh, okay. So g of x is the square root of 1 minus x. Let me just make up some more. Let's say k of x is 1 over 1 minus x, and L of x is the natural log of 1 minus x. Okay, now, what's the domain of this really is based on what the restriction is, right? What must be true about the number 1 minus x?
Must be greater than 0.
Yeah, the inside has to be greater than or equal to 0. I like it. So if you add x and turn around, x has to be less or equal to 1. Or if you subtract 1, divide by negative, you got to flip the sign and you finally get there. Okay. What about this one? What's the restriction? The bottom can't be
1.
no, x can't be 1, but the bottom can't be 0. Okay. So the bottom can't be 0, so x can't be 1. I like it. So yes, you got the right answer, but my point here is if you can say what the restriction is, you can write it in math and then solve it. That's how you basically do any domain question. If it's a function they give me, I say in words what the restriction is, write that down, solve it. So what about this guy? What's the restriction on the inside of a log? Yeah, it's got to be positive. Quick way to say that, right? So 1 minus x has to be greater than 0. It's a little more restrictive than a root. And so you get x has to be less than 1. Because if it equaled 1, it'd be a natural log of 0, and that would freak out. In a way, the natural log of 0 is negative infinity, but That's the same thing as saying it ain't nothing, right? But you can't get there. When are we going to go to the park? After an infinite amount of time. Well, just say we go. Same thing. I gotta be careful now. I actually have kids in my life. I gotta be. Why are you going to the park?
For 3b, I ended up getting x squared minus 6x minus 9 equals 0.
Yeah. Ooh, it's so evil of me. And that looks like it wants to factor, but it don't. So what do you do when you have a quadratic that won't factor equation? You use, of course, the quadratic formula. That's what it was created for, right? So that one you just have to use quadratic formula. Let me go ahead and give you guys, I'm going to give you guys the answer key so you can see which ones I did not do, and we can do those if you want to. I just got lazy. Put some purple at the bottom because I couldn't find my pen. That's fine. Oh, yeah. So I think that's what I was doing this morning. Number 9, there just wouldn't have been enough room, so we can do those together if you want to. You can leave your friends behind. Let's see that. We did 12e, we did number 14. Number 13 was, I think number 13 was the ellipse and hyperbola problems, maybe. I'm hoping. Page 901. Yeah. 14, 18, and 24. They were all circle, ellipse, and hyperbola. So that's number 13. I definitely wouldn't have had room on there, and I just didn't feel like getting another sheet of paper out. So you guys want to look at number 9? So what kind of numbers can log base 3 deal with nicely, right? I can't do log base 3 of 5 easily, right? You now know the change of base formula, you can get it, but I don't want to plot that.
9.
Okay, so good. So we're thinking about what numbers I want to have end up in here. So if I did use 10 for x, now what number, Jeff, yourself. So if a 9 is in here, it's easy, because what's log base 3 of 9? 2. So how do I make a 9 show up? I make x 10. So if x is 10, I get 2. Is that cool? Now go down from there. What's the next number down from 9 that it can handle? Probably a first power. 3. And how do I make 3 show up? I put a 4 in. Good. You guys start to see how to look at functions, figure out what x values to use so that you can plot it easily. This is going to be really useful in pre-calculus if you're able to do that. And if you get a teacher that actually makes you do it by hand. Right? So you get 1. What about below that? Next number below 3. 1. And how do you make a 1 show up? 2. 2 minus 1 is 1. Log base 3 of 1 is 0. And how about below that? Oh, shit. This one's going to be a little bit trickier. 1/3. And what do you put in there to make 1/3 show up? Probably 1/3 more than 1. So, yeah, 1 1/3, 4/3. So if I put a 4/3 in, 4/3 minus 1 is 1/3. What's log base 3 of 1/3? Negative 1. But do you understand where these numbers here? These are the numbers I have control over, and I'm picking them so that it's easy to do log base 3 of them. Now, this will be the trickiest one to plot, but oh well. Also, what's the domain of this? How do I figure out the domain?
Just minus 1, 3, 2.
So x has to be greater than 1. All right, how are we doing so far? Is that? All right. In fact, at 1, what's going to happen at x equal to 1? Where is there an asymptote normally for log? On this axis, I like it. Now, what has this done? The x minus 1, it shifted everything over. It's shifted everything over 1. So where's the asymptote going to be now? At 1. And now I'll use 1, so there's going to be a wall at 1. Right? Thou shalt not. You can't. I love this shirt, man. It's for so many reasons. So if this was x plus 2, where would the asymptote be? Negative 2. I mean, that idea of translation, that idea of moving shit around and being able to look at a function and see where things end up, it applies to anything about the graph. Asymptotes move the same way. Centers move. Anything about the graph moves the same amount as everything else. So asymptotes move. This one moved over 1. So now I start the graph. So let's see, 1, 2, 3. Where do we go up to? I'm not going to go up to 10. Screw it. Well, maybe I could. Maybe I won't. So what do I got? 2 at 0. 4/3 it's negative 1. So 1 and 1/3 it's negative 1. 4 it's 1. That's pretty much all I need there. I got the most important points. I got this curve here. So it goes from when it's just like dropping forever and when it's climbing really slowly, that curve in the middle is important. Jeff, just let it go. All right, that's fine. Plop. That's it. So you've got to know a logarithm looks like this. So all I got to do is find a few anchor points. I normally say I want like 3 anchor points at least, so I didn't need this last dude. And then I can just put the shape on top of those points. That's all it takes. I like it. I like it. Well, trust me, it's really obvious when you get the answer from, like, I don't know, a graphic calculator, because you guys do interesting things trying to translate what you see on the screen to your picture, to your paper. Right? If I were you, I would certainly graph it on my graph. Hell, shit, I got it. Might as well graph it on there and look at it and say, oh, I see. But now you know what to expect when you do it by hand. Right? Don't just try to copy it, trust me, because you're going to see something wrong, and I'm yelling, oh, I see what you did. None of that shit here. Okay, it better match up with what you've done by hand. I love that too, when these are totally different numbers and the right answer shows up. I'm like, how the hell with that? I'd much rather you plot what you found, even though you made major mistakes. I'd much rather that. What about part B? That's going to be a little bit easier, to be honest. What did I say there? G of x is 3 to the x minus 1 plus 2. The reason this is a little bit easier is because the domain is all real numbers for an exponential. You can raise a number to any number you want to. You just got to be a little bit careful, but let's see what you guys come up with. Where do you want to start with this here? It's actually a little bit better to start with 0, believe it or not. You want the fraction kind of stuff to show up because that's kind of like where the curve is happening. So if I put a 0 in, you do get something a little bit gross, but oh well. 3 to the negative 1 is 1/3 plus 2. It's 2 1/3, right? And that I can approximate on a graph pretty easy. And then of course, when I put a 1 in, what do I get? 3 to the 1 minus 1, 3 to the 0 is 1 plus 2 is. That's crazy. And then when I plug a 2 in, see, I don't have to be as careful with this. Here, I was doing something that only works nice with certain numbers. Here, when I raise a number to it works nice for almost everything. So when I put a 2 in, 3 to the first is 3 plus 2 is 5. That's plenty. Okay, and then I just plot those. Where's the asymptote going to be for this? Where is it normally for an exponential? No, careful now. Where is it normally for an exponential? Where's the asymptote normally? It's going to be here, right? That's what an exponential looks like, right? You got to know this. You got to know what an exponential looks like. Why is it going to be here? Because as I raise it to bigger and bigger negative numbers, it gets smaller and smaller and smaller. That's why. So know the asymptote here is going to be, so wherever anything was, it is now 2 up. Everything's been increased by 2. So if it used to be at 0, now it's going to be at 2. Let that be easy. Everything moves by the same amount. So now there's an asymptote at 2. And now I can start to plot stuff. At 0, it's at 2 1/3. 2 1/3, plop. At 1, it's at 3, plop. At 2, it's at 5. You gonna plop again? Sure. Plop. And that's basically all I need. Those 3 anchor points to find that turn it takes. So it goes, oh yeah, there you go. Holy shit! Okay, cool. And if I'm you, I would just plug in the calculator and make sure it looks about right. But don't try to copy it from the calculator. It's where you make dumb mistakes when you try to do that are easy for me to catch. By the way, nobody asked me about this, but if you got homework back that has nothing on it, it's fine. It's just I prioritized by grading the people that got the lowest grades on the test or the people that turned stuff in before the test. So if you were neither one of those, I maybe never looked at some of your homework. So, yes?
We have to make corrections for the test 3, right?
You don't have to, but I mean, they're due tomorrow if you want to. For test 3? They're due tomorrow. Shit. And I try to give you an idea on the grade sheet summary how much corrections by themselves, how much change they make. That's huge. Tests are the heaviest weighted thing. So if you can increase that grade at all, it's going to be a big boost to the old GPA. Is that done with that? Yes. Cool. What else didn't I do? I didn't do like 12D, but hopefully that's not too evil. Just foiling that bad boy out, right? 9 we just did. 13 we can do if you want. I didn't do 7. We could certainly do that one if you want. That's the one that I'm sure somebody in here is like, I know which problem I'm skipping. Still going to pass, Jeff. Aha. I'm like, all right, fine, whatever. At least I made you do a few of them. So what do you guys want to do? Go to the beach. 6. Which one? Sorry. 6B. 6B. Oh yeah, 6B. Okay, thank you. I forgot about that one. What kind of problem is 6B? System of inequalities. I love it. So what's the answer going to end up looking like? What should the answer end up looking like? Right? On a coordinate plane. Just give me a couple lines and shadings, right? You have to know that before you start it. In a way, you do. Because if you don't know that, you're probably not going to get to the right answer. So x, let's see, x minus 4y greater than 8. Where'd it go? Jeff, you're not looking at it. And let's do it purple. 2x plus 5y less or equal to 10. Okay, cool. All right. So, of course, now you don't have to do this. There are people that find the x and y intercepts. But are the x and y intercepts always nice? No. All right. So it's better generally to just do what with these? Solve for y. Put them in the line form so you can see the slope and the y-intercept. It's not going to be as crazy. So if I solve for y, let's see if I can just take my word for it. Add 4y, subtract 8, divide by 4, I get 1. I get greater than 1/4 x minus 2. Do I get greater than? No, you get less than. Thank you. Yeah, add that, subtract that. Okay. And then on the second one, that'd be cool. Whenever I skip steps, somebody freaks out, but just do it. On the second one, I would subtract 2x, divide by 5, so I get y less than or equal to negative 2/5 x plus 2. I like it. So then if I want to graph, holy crap, that's the straightest line. I should have multiple markers in my hand all the time. Let's see. Okay, that should be good. So let's say I graph the first one first. How do I graph this dude? Okay. Is that what it was? Yeah, okay. Start at negative 2, I like it. And go up 1 over 4, I like it. So that's this guy. And what kind of line is it going to be? Dashed. All right. And then where am I going to shade? Beneath it. I love it. Or you could do 0, 0 test point. Is 0 less than 0 minus 2? Is 0 less than negative 2? No. So you don't shade that way. You shade the other way. But I like y. Where are the y's less than that line? Below it. Sweet. So I'd shade this way. All right. Now how do you graph the second dude? Start at 2 and go down 2 over 5. I like it. And what kind of line is that going to be? Solid. And I'm going to shade below again. So the answer is going to be where the shadings overlap in here. So if you look at a point like that point, what's special about that point? It's going to make both of these true. I like it. What's special about that point right there, this point, neither one of them is going to be true there. I like it. So in the real world, this is multiple restrictions, like a weight restriction and a current restriction and a whatever, and then you plot them and you figure out your safe space. Right? So you'll see graphs in engineering that sort of look like this. They might even be 3D, but they sort of look like this, and they have areas mapped out that's where I want to be with the shearing force and the strain and the stress and all that kind of business. They can figure out what a safe place is. It's one application. Okay. See, I won't build some building that's going to collapse on people. That's probably a bad idea. Yeah. Which one, sorry? P? 1P? Gonna skip it? No, there it is. So, you have a question about it? Exactly. Right? When I subtract a log, that's dividing by the inside, right? So the only log that's being subtracted, that inside is going to end up on the bottom.
How do you get that
100? Oh, that's my poor G got tired. I could blame it on the printer, but obviously that's just my bad writing. log base B, yeah. What's up? Oh, I'm sorry, man.
For 1E, I don't know what I'm doing wrong. I don't get that.
Yeah, it could be me. Let's see.
I'm at, I get the 5, x minus 3, x plus 3.
Oh, I left a... No, I guess I didn't. That's there.
3, and then I got x x squared plus 3x plus 9,
Sure.
or 5x over 3, 5x cubed. I know the x minus 3 they cancel.
Sure.
And the x squared plus 2x plus 9 they cancel. So I have 5.
But see, the 5s cancel.
Which one? Oh.
And then
So I
1x
have x plus
cancels.
3. So I have x plus 3 over x squared.
Yeah, that's it.
Okay.
Cool.
What's it, like on Q, after P, why do you switch it over? That's just what you do?
All right, so
'Cause I know they cancel log 3 and 3 cancel.
if they were acting directly on each other, they would cancel all day, right? That's the problem. So real quick, let me build up there. What's log x plus log y? I love that question.
Log X, what?
Log x, y, I love it. That was easy, because there's nothing in the way. What's log x plus 2 log y? Can't do that one, right? Because there's 2's in the way, but there is somewhere I can put it so it's not in the way anymore.
Square.
Now I can do just like we did in the first problem, right? Is that cool? That stupid 2 is in the way, I can move it up out of the way.
Is there a situation where you can't move it to?
Yeah, if it's not a log, right? Because log is the only thing that has that property where the power can come down or go back up. Right? That's the only function we've ever seen.
You can't bring it down yet? No. You do that everywhere?
Yeah, because if I had 2 to the x equals 11 and I just brought the x down, no, there's no property of exponentials where that can just happen. The power can come down and be multiplied. No, I have to take a log first because that has a property it can come down. No, and answer your question directly. If I had 4 to the log base 4 of y, that's easy. I shouldn't have used 4 and y, but oh well. 4 to the log base 4 of m. That's easy. What's the answer? M. But if I had 4 to the 2 log base 4 of m, doesn't work the same. Be 4 to the log base 4 of m squared. See, I do the same thing. If there's a coefficient in my way, I can just put it up in the power. Then it's not in my way. Now these can act on each other. They kill each other, right? And now the answer is m squared. I like it. I like it. Now watch. Let me show you a different way to look at this. Just because I like to confuse the issue. Isn't this 2 times log base 4 of m in the exponent, right? When do I multiply powers? When I had something being raised to a power to another power, right? So wouldn't this be 4 to the log base 4m squared? Because what would you do with these powers? What would you do with these powers? Multiply them, and you would be here again, right? So this is the same as this. What's 4 to the log base 4 of m? M squared. Same answer, of course, right? I mean, there's multiple ways to get to the same answer.
How do you
Say again?
cancel?
What? Say,
How do you cancel the
well, how do 4 to the x and log base 4 of x, how do they relate to each other? What's the relationship between these? They are inverses of each other. So log base 4 and 4 to a power cancel each other. The same way that the cube root and a cube cancel each other, the same way. Any opposite functions will kill each other. We've known that forever. It's just that we're not used to logs yet. But they're just inverses of this. They will kill each other. So you don't want to leave them alone with each other. A little log gang war happening now. It wouldn't be good. West log story. Yes?
Could you do number 10? Working on the answer key, and I see the vertex part. I just kind of could use a refresher on the
Oh, yeah. All right. Number 10 is another one I didn't really finish out.
So when you do the negative b over 2a, that
Yeah.
gives you that x value?
That gives you the x piece.
And
That's
then
right.
you have to plug it back in to get the y?
Exactly.
Okay.
I mean, if I know the x, how to get the y, plug it back in.
That's for the other parts.
So the axis of symmetry is just always going to be, so here's what I got so far. The vertex, after negative b over 2a, I got negative 3 halves and 11 halves. Yeah. Yeah, okay. And now if I want to find, what's the y-intercept? Let's start there because that's easy. What's the y-intercept?
That's equal to 0, right?
Beautiful.
So then it would be 1.
Yes, so 0, 1. Now how do I find the x-intercepts? Set y equal to 0, so negative 2x squared minus 6x plus 1 equals 0. It'd be awesome if I could factor that, but you can't. There are no factors of negative 2 that had to be negative 6. So I have to use... All right, you guys can all do that, right? Is that cool?
Parabola, you'll get 2 answers.
Exactly.
Okay.
They might be complex, which would mean your parabola starts above and goes up, or starts below and goes down. So it never hits the x-axis, at least in the real field of numbers. Blah, blah, blah. Negative b plus or minus, blah, blah, blah. Right? There you go, and then you can graph this bad
Axis
boy.
of symmetry.
Yeah, axis of symmetry is always going to be x equals the x piece of the vertex. Because wherever the vertex is, so it's negative 3 halves, so negative 1 1/2, and then 11 halves. So 11 halves, of course, is 5 1/2. So negative 3 halves, 11 halves.
And then that's
Axis of symmetry is going to go. It's going to be a parabola like this. So it's going to run right down the middle. It's going to be x equals the x piece of the vertex, because that's the vertical line's equation. Is x equals the number. Y-intercept is 0, 1. So where's there another point?
1 over.
Yeah, like 1 1/2 over, right? And now you've got it. Where'd it go? There it is. Poor little dude. You can double check. One x-intercept should be a small positive one. The other one should be just below negative 3. You can double check that when you do your x-intercepts. Yes, sir.
What's the vertex formula?
Oh, so x equals negative b over 2a. And then you do f of that to figure out the y piece, right? So an x piece and a y piece. The shortcut is for the x piece. And once you got that, you can get the y piece by plugging it back in. Crazy. Yeah.
To do 3D, I get it down to x squared minus 6x minus 9.
Yep.
And then,
That's not factorable, right? It looks like it wants to be, but it's not.
oh yeah, yeah.
So then you have to use what? If you can't factor it, you have to use quadratic formula, yeah. That's why it was invented. It was another way to solve quadratic equals 0 when I can't factor it.
I want to do the matrix.
Yes, so much. Let's see. me see if I can get you guys to understand what I would do. See the order that I wrote those equations? Does the order that I gave you the equations matter? Does it matter? It doesn't matter where shit. I just got to give you 3 equations. So which one is got a 1, basically, is the second one. All right, I'm going to write that in the first row then. Shit. Because that seems to throw people off when the first thing is not a 1. All this funky stuff happens to make it be, well, there is a 1. Just put that first. There's a negative 1 right now, but we can take care of that. So it'd be, if I wrote the second equation first, it would be negative 1, negative 2, 2, and 8. And then here's the first equation, 3, negative 1, negative 5, negative 7, and then 5, negative 2, negative 1, 11. It's kind of nice that it's a negative 1 already, because how would I kill this 3 here, knowing my goal, I want to make zeros. Multiply row 1 by 3. Add it to row 2, put the answer in row 2. And then I can multiply it by 5.
Answer in
That's row 3, answer in row 3. I like it.
And then would you take a negative 1 through the whole first row?
Huh?
Would you take
Yeah,
a
yeah,
negative
oh yeah.
1? Okay.
So let's see. So if I do 3 times this, would be negative 3, negative 6, 6, 24. So I write what 3 row 1 is, and then I add that to row 2. So let's see what I get. I get 0, negative 7, 1, 17. Is that cool? So I'm done with those. Blah, blah. Go away, go away. Now I do 5 row 1. So negative 5, negative 10, 10, 40. And I add it to row 3. So of course I get 0 here like I wanted. Negative 10 minus 2. 10 minus 1. And 40 plus 11. And then the first row just... Now the first row I could multiply by negative 1 if I wanted to, right? So that would be 1, 2, negative 2, negative 8. Okay. Yes.
So, going forward, at what point do you kind of go for the GCF? Because doesn't the third row have the factor?
Good, exactly. Anytime.
Anytime?
Yeah, hell yeah. Unless, I mean, if that was a 12, I would leave this the way it is because it would cancel already. But I'd rather reduce these numbers and see if I can't deal with this stupid 7 there.
How do you get the top row to be 1 again?
Oh, I just multiplied, so row 1 times negative 1. So row 1. Just multiply by negative 1. Oh.
Oh, you multiply by itself. Oh.
Multiply by negative 1. Something I've seen people do is, if I have an equation sitting here and another equation sitting here, I can add these together, right? Can I multiply this equation by that equation? Doesn't make any damn sense. So I can't get a 0. I can't, if I have 0 there and I wanted a 0 here, I can't multiply these together. It doesn't make any sense. You can only do to rows what you can do to equations. Why? Because the rows are frickin' equations. That's it. So don't come up with the creative ways to make things happen. No. You can multiply a row by a number because you can multiply an equation by a number. And you can add 2 rows together. You can subtract 2 or whatever. Now, the suggestion right now, what goes into all 3 of these? 3. So I could take row 3 divided by, let me just go ahead and say, negative 3. Let's see if that makes this thing look any better. 1, 2, negative 2, negative 8. 0, negative 7, 1. Become negative over there. There you go. 17. 0, 4, negative 3, negative 17. Now, there's a couple creative things we could do. You could either just remember what Jeff said and say, I don't need a 1. You don't need to have a 1. Because what I want to do here is I want to kill like this 4, right? I want to have a 0 here, don't I? So I could just multiply this row by 4 and this row by 7. Do you see that would be like an LCD kind of thing? Do you guys see that? I could also double this row and add it to this row, because what would happen then? It'd make a 1, all right? I could make a 1 if I really wanted to. And why is that actually a little bit better way to go? Because then I can use that 1 to kill that 2. I don't have to, but that's a little slightly better way to go. So if I did double this row, double row 3 plus row 2, answer in row 2, let's see what happens. So this would be 0, 8, negative 6, negative 34. So doubling. And so in the middle I get 0,